In this video, I'll be helping you with the math topic called using the zero exponent rule, seen here in the OpenStax College Algebra 2nd edition text. We start with the rule that says when a is non-zero and it is raised to the zero power, so any base that is not zero raised to the zero power will always equal 1. And since we're taking a base raised to a power and saying that that's equal to 1, this will often lead to a lot of simplification in an expression. And I'll start here with example A, where we have c to the third over c to the third. The quotient rule says that when we have a base raised to an exponent divided by that same base raised to an exponent, that we can keep that base, and our new exponent will be the power of the top minus the power of the bottom. Notice that this simplifies to c to the zero power, which we now know is 1, so that a expression simplifies to just 1. Our b expression has negative 3x to the fifth over x to the fifth, which we can rewrite as negative 3. Since the x to the fifth and x to the fifth have the same base, we can again keep that base with the power of the top minus the power of the bottom, means that we now have negative 3 times x to the 0. And notice that only x is being raised to the 0. So only that part of the expression simplifies to 1. So our b expression simplifies to a minus 3. For c, we can start the simplification process by noticing in the denominator we have this same j squared k, here raised to the 1 power, times the same base j squared k raised to the third power, means that we can simplify that denominator. With the product rule, we know that we will keep that base, j squared k, and that the exponent will be the sum of 1 and 3. I'll go ahead and say that that is 4. Bringing over the numerator, we can see that again we have the same base, j squared k, and now since it's being divided, we keep the base, subtract the exponents. 4 minus 4 gives us a 0, and now we can use the zero exponent rule since the entire j squared k is a base being raised to the 0 power. This simplifies as just 1. For 5, we see in our expression a common base, rs squared, being raised to exponents. The 5 is not a part of that, but since those bases are the same, we can write it as a single base, rs squared, and then the power of the top minus the power of the bottom again gives us 0. The base raised to the 0 exponent would simplify to 1, and then 5 times 1 is our simplified expression.